Hi, everybody. Good evening. Audio scanning, and you're able to hear me.
Good evening, sir.
So good. Let's get started with today's session. And today is going to be a little bit of more of a theory session because we're planning to now start actually working on query optimization and looking at individual queries. But before that, there's some basic understanding and fundamentals which it will be great that if you get. So very good evening to all of you, and we are ready to get started today. I guess a lot of you are from different parts of India. Most probably you are connecting. In Bangalore, it's a very rainy day today. And I won't say great weather, but it's nice to look at the rain out of your window. Welcome back to the session. I'm going to start by sharing my desktop. And we are going to do a little bit of theory. Now, this is very, very important for you to understand and visualize this. So feel free to ask me questions in case the visualization is not clear and there is anything more that you'd like me to basically add in order to make the visualization as clear as possible. Because this is the foundation of your understanding query tuning better and understanding how to query those queries. Because that was a tongue twister there for me. Understanding how you can actually fine tune and understand what's really happening on your queries. So having said that, I'm going to use a deck today. We've already understood in the past the primary files, the secondary files. We've not spoken about the transaction log, but I have covered and told you about the tempdb. I spoke about where you can place those files and also gave you recommendations of why the tempdb is important. Today, we're going to talk about how exactly data is stored. So now I'm giving you a picture of what we discussed in yesterday's session. Whenever you create a MDF or an NDF file, these files are broken into pages, which are called 8 KB blocks, which are called pages, as you can see in the diagram. I hope the slide is visible to everybody. If it's not, just sound me out because I won't be able to see your chat right now. I've got the deck in full point, full desktop. So in presentation view. So in case you're not able to see the deck, just sound me out, unmute your mic and just tell me that the deck is not visible. So we've got these 8 KB pages. Now, these are the blocks which basically store data. We've understood the basics of the page yesterday. We've understood we've got a 96 bytes page header. We've got some space which is taken for the page footer. That's what we understood yesterday. Moving on from there. Now, every page, or rather, let's put it this way. Every 8 pages together make up what is called an extent. So there are 2 words and terminologies that you use here. One is a page, which is nothing but an 8 KB block on which your data gets stored, and you have 8060 bytes of data, which you can store on a page. And 8 of these pages together is basically called an extent. And pages itself are of 2 types. So you have pages that will track space allocation. Now, you guys need to visualize this. So don't try to understand the definition. Just try to understand what I'm saying and try to basically build a picture in front of you of it so you can visualize it. Now, when you create a file, there are going to be tons of pages in that file, depending on the size of the page file that you create. Divided by 8 KB. Together will make up maybe hundreds or thousands of pages, depending on how large that data file that you created is going to be. Now, whenever a table of yours needs to store data, it needs to basically find a page, right? So this is most probably visualize this as a book, a series of empty pages. The book has 10,000 pages in it. Now you want to put some data there. Now you need to decide, you need to understand which page can you basically put this data on. Now in this 10,000 page book, some pages might be already occupied with some topics which you're writing about. Some pages might be free. Some pages in between could be free. Some pages towards the end could be free. Some pages could be fully occupied. Some pages could be partially occupied. And what data you're trying to put may be related to a topic which you already have on a particular page, and that page still has more space, which means you can continue writing on that same page instead of taking a new page. Now, all of these, if you're thinking of it as a book and thinking about it as topics, your tables could be topics which you're writing about. So maybe you have some pages free, not yet been used, and this is a new topic, so you'll give it a new page. Or it could be you're trying to basically update or you're trying to add information on an existing subject, existing topic. And maybe you need to find what are the pages which already have this information. And maybe you can use, if there is free space on those pages, maybe you can use those pages first. And after that is full, then maybe you can allocate a new page. Now, all of these is a visualization for you. You understand this is the coordination and the organization that you'll need to basically come up with if you were working with a book and were working with the data there. Now you can relate this in SQL Server to your topics, which I call topics, are your tables. So we have a customer table, which means we need to store customer data somewhere. We have a products table, which means we need to store product data somewhere. Now the system, SQL Server, has the same confusion as you would have when you are trying to basically put data in a book, which has free pages. The first question would be, does the customer table already have a set of pages? Do we already have customer information being stored somewhere? If it's being stored on a set of pages, do any of those pages have free space? If those pages have free space, can I use it? Or if none of those pages have free space, then what do I do? Do I create a new page? Okay, so these are decisions which the system has to make. Also, there could be decisions related to, this is a new table, so we don't have any pages at all allocated to it. So this is the first time someone wants to allocate data to this page, to this particular table. So then we'll need to go search for a new page, allocate it, and then someone needs to keep track. Because let's go back to your book story. If you had a book and you were going to basically store data in multiple different pages based on topics, and you're already writing a topic which is occupied 5 or 6 pages in that book, somewhere you might need to basically keep track of the topic called, let's say you are writing on a topic called SQL Server. So the topic called SQL Server currently has 5 pages which are being used, and these are the page numbers. Someone needs to keep track of that. Otherwise, every time you want to write data or you want to write information on the topic, you won't know which pages in this 10,000 page book is actually storing data for the topic which you are interested in writing about. I'm hoping you're understanding the problem statement right now. Okay, it's as simple as you making this visualization. I'm going to pause here because these concepts are very, very critical in your understanding query optimization well. So in case there's any questions right now and that visualization is not clear, please feel comfortable enough to basically shoot questions at this stage. No questions? Excellent. Okay, I'm hoping that visualization is clear. So SQL Server, now you've got a table, customer table, you need to put in data. You need to basically decide which are the pages that are storing customer data. That's the first question. After he finds all the pages that are storing customer data, he needs to now basically understand whether these pages have free space. If they have free space, is that free space enough to insert the new row or new records which you're trying to insert? Or maybe it has free space, but your row size is larger than the amount of available free space on that page. So this also needs to be tracked. Now, there is a set of pages in SQL Server which are used dedicatedly only to track space allocation. In other words, this is used internally by SQL Server. A set of pages. And these pages are used only to keep track of which pages are being used by which tables, what is the percentage of free space on these pages. Okay, are these pages basically, is the size good enough for you to be able to insert a new record? Is it not good enough for the new record? So you have a set of pages that track the entire allocation of how space is being allocated to your objects, to your tables, which you're creating in the system. So when I said pages are of 2 types, okay, I said one type is the pages that are not used by your data, not used for storage of your table data, not used for your indexes. It's used only for SQL Server internally to track which pages are being allocated to who and what are their occupancy and so on. So these pages, we will call them the pages that track space allocation. The second type of page, of course, is the page that stores your data or your indexes. Okay, because indexes have to be stored. If you had a book, you would have an index, and the index will need to basically definitely store data. Because when I say data, it has to store the index information, your keys, your pointers, and so on. So the second type of pages are the pages that actually store your user data, your table data, and any indexes that you might build on that particular data. So these are the 2 types of pages which are available. So 2 concepts that we are trying to cover on this slide here. One, we've understood pages are of 2 types. We know there are pages used by SQL Server to track space allocation. And we also know that there are pages which are used to actually store your user data, your table data, and your indexes that you might create on them. 8 consecutive pages, I told you earlier, is called an extent. Now, this is the second concept we are talking about. Now, extents are of two types. We say mixed extents and uniform extents. Now, if you're looking at this visualization, which you see on the screen, you will see my first extent here is a mixed extent. The colors here are representing most probably tables. You can assume for the visualization sake and for the understanding of the concept that they represent tables. So each color here is a different table. So you will notice the first page is basically now allocated to one table, the second page is allocated to another table, the third page is allocated to another table, and so on and so forth. If you're looking at that first block on that slide, which I'm basically currently displaying to you. Now, these 8 pages, which are together, are all having data belonging to different tables. So in this case, this is called a mixed extent. However, if you're looking at the other 3 blocks on this visualization, you'll see they all have the uniform colors. And going with the concept that a table is represented here by color, it means that the second block that you're seeing on the screen is a block which is being used only by a particular single table. Now, when a block is being used only by a single table, this actually means that this block is called a uniform extent. Now, while this concept is very clear, you understand a mixed extent means you most probably have different table data being stored in different pages. And if all the 8 pages together are storing the data from the same table, then it is called a uniform extent. In addition, you're going to have free space. You're going to have pages that are not yet used. So 8 consecutive pages that are free is also called a uniform extent, but it's a uniform extent that has not yet been used. There are 8 consecutive pages that are free, not touched, not allocated, not used. It's still a uniform extent, but it's a uniform extent that has not been allocated to any table. Another interesting concept at this stage to understand is you cannot allocate a single page to 2 tables. A single page can only be allocated to one single table. You cannot allocate it to multiple objects, which means pages are not shared. So if you're trying to relate this to your book concept, if you had a particular topic which you are writing on, you cannot basically have 2 topics on the same page. That's what it means, because SQL Server will not assign or allocate the same page to a second table. If you're creating a table called X, and this table X has basically been assigned this first page, it cannot assign this page to any other table in the future. So this page will be used only by the table X. Okay. So that's some basic fundamentals on terms of your storage and your structures of how our pages work. Now, continuing on this, I'm going to the next slide. Now, we spoke about pages that are used to track space allocation. So in every file, I repeat here, it's every file. So if you have multiple data files, if you create multiple NDFs, and MDF, of course, you can have only one. If you have multiple data files, this architecture which I'm talking about is for every single data file. So every data file that you create, the first 8 pages, you can see these are 8 pages. They are numbered from 0 to 7. The first 8 pages are used by the system. You cannot basically use this to do anything that you want. This is used by SQL Server for sure. And the minute you create a file, these 8 pages are grabbed. SQL Server takes them away, the first 8 pages, and he says, buddy, you cannot use them. This is for me, because I'm going to use these 8 pages to track space allocation. We spoke about 2 types of pages, one to track the space allocation. These are the 8 pages that would be used for tracking space allocation. Now, in case these pages are not enough, because naturally a page comes with a limitation, it is 8060 bytes in size. I mean, you can only store 8060 bytes of data, it's 8 KB in size. So whenever these pages get full, SQL Server will automatically create a new page and link this page to that particular page, which means they could be multiple, they could be more than 8 pages in your file, which is there to track space allocation. But when you create that file, 8 pages are automatically taken to start with. And as these pages get full, SQL Server will create new pages as to wherever a page is available. It may not be next to them. It may not be side by side. A very important concept, because performance also has something called fragmentation. The more fragmented the pages are spread across in multiple places across your file, multiple places across your hard disk, would mean that fragmentation has occurred. And fragmentation would mean slower performance because it's taking longer to read these, go and locate these on your hard disk and read from them. So the first 8 pages are, of course, together, but pages after that are wherever a page is available, they are taken. However, there is a chain maintained between these pages. So there will be a link maintained on each of these pages, taking you to the next pages that they are basically using, so that you won't have to go to multiple pages. You just go to the any of these 8 pages, and when you read through that page, it will automatically take you to the next page in case there was a next page requirement for to track space allocation. Now, the first page in this data file is referred to as a file header, and you will see that here. This is the guy that actually stores all the information about the file. For example, information like what is the size of the file, what is the growth if you've set an auto growth, what is that auto growth, what is the current space used by that file, which is actually a dynamic figure if you think about it, because as you're modifying data, inserting data into your tables, the amount of space available on that file is going to keep changing, but that information will be tracked on this first particular page, page 0, which is called the file header. And this is available on every single file. Now, another thing for those of you who are basically people who can structurize databases and work on basic structures, it will be a good idea to basically ensure you create multiple data files, especially if you have very large databases, because these pages are so constantly used. If you basically have two files, it means you have 2 sets of pages, right? Which also means that the contention, okay, the competition to get this information is going to be lesser. So if you're going to have very large structures, then I think it's a good idea to basically have multiple data files. Okay. So at least you can have duplicate copies of these first 80 pages, and the system can basically read from them concurrently as separate files, because separate data is tracked in separate files. So the file header, you've understood. The second page is called a PFS page. Now, what the PFS page actually stores is information about the free space on each of the pages that have been allocated. So if you have a page allocated at any point of time, this will store information about the free space on that page. So let's say we've got 20 pages which are allocated. So each of the IDs of those 20 pages will get listed here with a bitmap indicator indicating the percentage of free space on that page. And I think now you'll understand why it's called PFS, pages free space. So the second page of every data file, in this case, the page number 1, which you're looking at in the visual, will store the address of every page in the data file with a bitmap indicator indicating the percentage of free space on that particular page. Is that clear? PFS is good? Great. Pausing there, just in case any of you want to shoot a question. And guys, feel free to trouble me, feel free to break my flow, feel free to ask questions in case there's something which you're not able to understand, not able to visualize. Just shoot the question, because if you wait for the end, maybe you'll forget the question. So that's the PFS page. The third page of every data file is what we call a GAM page, which stands for Global Allocation Map. Now, what does this store? What does the GAM page store? This is the third page on every data file. Now, the GAM page basically stores every uniform extent. Now, I hope you remember the definition of uniform extent, which I explained on the previous slide. A uniform extent is basically 8 consecutive pages that are either free, which means it's not allocated, or are allocated to the same table. In both cases, they are called uniform extents. One, a uniform extent that has been allocated, and if the 8 pages are all free, it means it's a uniform extent that has not been allocated to anyone as of yet. So the third page of every data file, which is called a GAM, which is for Global Allocation Map, stores the ID or the address of every mixed extent. I repeat, of every mixed extent that is free. Meaning, if I go to this page number 2, and I pick up an address here, and I go to that location, I am guaranteed to find 8 free pages, right? Because only then the address will be here. Otherwise, the address will not be there in the GAM. The global allocation map will have the address of an extent only that has not been allocated. Now, this is very interesting and amazing. So whenever SQL Server says, buddy, I want 8 free pages. Okay, you can think about your book. You want 8 free pages. Instead of you basically going looking at where they are available, you just go to one page, which is most probably telling you, this is the place if you go to, you will find 8 free pages together. Okay, so that's what the GAM does. And how does it fulfill its role here? And how is it useful? I think very simple. We've just answered the question. If SQL Server at any point of time wanted to give 8 free pages to a particular table, he needs to find those 8 pages. So instead of going hunting the entire file, he will simply come to the third page in the data file, which is this page number 2. And in this third page on the data file, the first address that he picks up from here, he knows for certain that this now is a place, if I go to on the disk, I will find 64 KB of data, 64 KB of free space, right? Because each page is 8 KB, so an extent is 64 KB. So he's certain now that he will find 64 KB of free space. Are you guys clear with this? So that's the usefulness of the GAM. The third page, the fourth page of every data file is an SGAM, shared global allocation map. Now in this one, it will also store the address. The only difference is, I will say this as slowly as I can, okay? It will store the address of every mixed extent. I'll stop at that. It will store the address of every mixed extent. Now, we all know what is a mixed extent. A mixed extent is 8 pages that belong to different tables. They are not free. They are not all belonging to the same object. Okay, some of them, they are all scattered across multiple objects are using different pages in those 8 pages. So that's a mixed extent. So it will store the address of a mixed extent. I'm assuming that's clear. It will store the address of a mixed extent that has at least one free page. So the difference is it will store the address of a mixed extent that has at least one free page. So the important criteria here is that for the address of a mixed extent to get stored in the SGAM, it needs to have at least one page there which is not allocated. And now if you're thinking, why do I need this? Simple. Now, sometimes SQL Server wants to give your table one page only. When he needs to find one page, he will not go to the GAM, he will go to the SGAM. And he knows when I find the address of an extent here, I will definitely, when I go there, I will find at least one page that is free, which means I can use it. I can allocate it to your table. Fine. And when he needs to allocate 8 pages to a table of yours, he goes to GAM. And when he picks up the address there, he's certain that he will basically find an extent which has 8 free pages when he goes to that particular location on your disk in order to store the data. So these are the 4 pages which are very critical in what we call space allocation. It is responsible for you to basically, and without these, and guys, you need to understand now, these are all dynamic stuff. See, I don't know for how many of you SQL Server was magical. You say select star, you say insert, and everything simply happens and returns results come in. But you can see in the background the amount of effort that has to be put. When you do an insert today, into a table. Let's take an example. You say insert into customer tables, put in your values. Now this record has to get inserted. First question is, where do these records get inserted? First, the system needs to find the object ID. After he finds the object ID for that particular table, he goes to sys.objects, which is a system table. So he queries the system table, he picks up the object ID related to it. Then he again queries the system tables and finds out which are the pages which it needs to go to in order to get data related to the customer's table. After he finds all the pages that belong to the customer's table, he will then go to the PFS page, search for those pages, and look to find out if any of those pages have free space. If any of those pages have free space, he says, great, let me put the data into those pages. Now I found a page which has free space. I found a page that belongs to the customer table. Now let me insert your record there. Now, if he's gone through all the pages and he does not find any free space, then he says, great, I need to allocate one more page to this particular table. Now, to find one free page, he has to go to SGAM. If he goes to the SGAM, he knows for sure he will find an extent that has one free page. Now, he will pick up that page, allocate that page to the table, put that page into record that now this table customer, he has one more page, puts that into a record. I'll show you where that record is put on the next slide. Okay. And then basically does the insert. Now look at that work. Now, I also want you to imagine and understand at this stage, if you're having thousands of inserts happening at any given point of time, you need to understand that PFS, GAM, and SGAM are being drastically used because every query now needs to basically go to PFS, GAM, SGAM. And that's why I said splitting your database into multiple files is beneficial because then you'll have multiple PFSs, multiple GAMs, and multiple SGAMs. So some tables could be located in file 1, some tables will be located in file 2, some tables are located in file 3. So when he needs to find the table which is related to the file, you will reduce contention on these pages. Okay, because otherwise, a lot of times I've seen performance problems are because of these pages, because these pages are basically now having a lot of frequent activity and multiple people are trying to read to them, update them, and so on. And then you'll see a lot of spin locks basically occurring, which are nothing but a smaller resource utilization locks, which are created by most of the system pages. They're called spin locks. So you will see basically a lightweight lock being created on all of these pages in order to ensure the contention is basically managed. And reducing this contention, guys, the only way to do it is to basically ensure if you're having too many objects, you're having too many tables, you're having very large data files, please split them, make them smaller. I won't really be able to tell you here that what is small and what is large, because that's definitely something which you might need to basically look at from the performance of your disk drives and other things. But it's always good to see if you can arrange and split your tables across multiple files, or even one table across multiple files would work. And I will show you how to do that when we start the demos again. So that was you understanding a couple of things in terms of the PFS, GAM, and SGAM, which are the first 4 pages. Okay, file header, which are the first 4 pages together of every file that you create, data file that you create in SQL Server. Now, I have not explained to you the other 4 pages, okay, and I'm going to leave that out because it's not related to queries and optimization. It's more related to your administration. For example, if you're doing a differential backup, a very good question which an administrator should ask is, how does the system know what has changed? Okay, how does it pick up? How does it back up only the differences? Now, some of these pages in 4, 5, 6, and 7 are used to basically track that information. For example, you have the page number 4, which is a DCAM page, differential configuration allocation map that keeps track of all changes that happen on a file after a full backup is taken. So whenever you say differential backup, it goes to page number 4, picks up all the pages that have changed and only basically backs up those pages. But like I said, a discussion for another day and another training. So I'm not going to go ahead with 4, 5, 6, and 7. I'm pretty sure you understood 0, 1, 2, 3. And they are very relevant to your understanding and visualizing what your queries are doing. Because guys, there's one thing about, let's say you basically had a bike and it basically was traveling at 60 kilometers per hour and you wanted to make it faster. One of the best ways to understand that is to understand how your engine works. Once you understand how your engine works, you will be able to understand what needs to be done in order to make it go faster. And that's exactly what we're trying to do in this series by trying to tell you to visualize and make you understand what all work actually takes place to execute your query. Because as you start understanding that work, you will be able to understand how to optimize those queries by reducing the amount of work that it's doing. Now, moving to the next slide here. Now, every time you create a table, now I've just tried to basically visualize this. Guys, this is conceptual, so don't try to make this look like practical. This is basically more a storybook to just help you visualize and understand the concepts. So I've just basically created some colors here. We've got 2 types of extents. You can see the mixed extents and uniform extents. And here you will notice the black colors that you see on the slide represent free pages. It represents pages that are not yet been allocated. So you'll notice in my 2 mixed extents, my first mixed extent, which you see on the screen, you will notice that I have 3 free pages on this. This is my first mixed extent, and you'll see 3 free pages here. The black pages represent free pages. In my second mixed extent, you will see we've got 6 free pages. 2 pages have been occupied by somebody. Here also you see 2 pages occupied by somebody. Sorry, in the first extent, you see 5 pages occupied by somebody, the yellow and the green. In the second mixed extent, you see 2 pages. These are still mixed extents, like I told you. The reason why they are mixed extents, because to be a uniform, either all 8 have to belong to the same table or all 8 have to be free. Otherwise, it is not a uniform extent. So these both are mixed extents, meaning their addresses will be in SGAM. So the addresses of this particular file will be in SGAM. That's for sure. Okay. And here you see I've got two uniform extents. One which is already allocated. This is the allocated uniform extents. And this is free. This extent is free. Okay. It's 8 free pages which are available together. Okay. Which means the address of this would be in the GAM. These two extents, the address will be in the SGAM. Yeah. Now, having brought that to your notice, now let me basically see how, let's say you create a table, the table is new. Nothing happens when you create a table, space is not allocated at all. But when you try to do the first insert into that table, the system will realize, boss, this is a new table. I need to find a page for it. And what he does is, the first thing he does is, he basically finds a page and allocates it to the table, not to store your data, to maintain the record of all the data pages used by this table. So this first page, which he will allocate. So let's assume in our example here, this is the page which he will allocate. I'm just going to see if I can. Right. Yeah. So let's assume in this example, I hope the slide is still visible. Excellent. Let's assume that it's going to allocate this page. Now, this page is not going to store data. So you created a new table, you're doing your first insert, and it needs to find a page. So the first page, let's say he finds is from a mixed extent, because if he wants one page, naturally he goes to SGAM. SGAM gives him the address of the first mixed extent. He finds this as the address of the first mixed extent. He says, amazing. Now, after finding that, he basically finds the first free page there, which is the one which you're looking at here, the first black one, the page number 3. And he says, amazing, I've got this page, which is free. Now, he allocates this to your table, but he does not store data on it. Now, this first page that is allocated to your table is called an IAM page, which stands for Index Allocation Map. Let's say this page number was 3, okay, for the record. So page number 3 now gets allocated to your table. Let's say you are creating a table called customers. So page number 3 gets allocated as an IAM page, not a data page, which means it's not going to store your rows. Okay, it takes page number 3 and allocates it as, oh, that doesn't look like 3. Anyway, that's 3. Okay, so it takes page number 3 and allocates it as an IAM page. Now, this is, let's assume, the address of the page. Now, what he does is he goes to a system table, which is there in your database called sys. There are multiple system tables. I'm going to give you one, sys.indexes. And here you will create a record. This is metadata. This has nothing to do with data. You will create a row here. You will take this page address 3 and you will put it here under a column called first IAM. First IAM, index allocation map. He stores page number 3 here. Now, this is the first thing he does, guys. Now, this page is no longer non-allocated. It has been allocated. Okay. Page number 3 is done, taken. Your table called cust has basically taken this particular page number 3. Now, after it's taken this page number 3, the next thing which you will do is say, great, I also have to insert the record. Okay, so what do? I need to find another page. Again, he goes to your SGAM, finds the first mixed extent, which if you're looking at the scenario on the slide is still this one. So he picks it. And now the first free page here is this page number 5. Now he takes this page and allocates it to your IAM, to your table. But this one is not an IAM page. This is a data page. This is the page where you will start storing data. He takes the address of this page, which is the data page, and he stores it on this IAM page. So 5 gets inserted here, and this is what would basically happen. Okay, so the table called customers now has a blue page, which is your IAM page, index allocation map. It has a purple page, which is the first data page, and this is where you will insert your record. So your record will get stored here. This is where your record will get stored. And the IAM page now has the address of this data page. Are you guys with me? So it's as simple as that. Now, once you try to insert a second record now, he goes to the system table. He finds page 3 is the IAM page for this particular table called customers. Now he goes to page 3. He finds that the data page here is 5. Now, if you're going to make the story very long, he picks up this page 5 and goes to the PFS page, which is the second page in every data file. He checks to see what is the percentage of free space on this page. If there is enough free space and the record size that you're trying to insert is basically smaller than the free space that is available, you will go ahead and continue to insert the data in page 5. Now you will do this, the cycle will continue until page 5 is full. Once page 5 is full, he says, boss, I need another page. Okay, there's no more space. I've got only one page that belongs to the customer table. Because I go to the IEM, I find only one page, there are 5. I go to the PFS and I look at page 5's free space and I say there is no free space. So I need another page. At this stage, he will again go back to SGAN, find the first mixed extent, which in our case of this particular PPT, because it's a limited size one, I've got the same mixed extent that has free page. So he gives me that address. Now the next page 6 will get allocated as a data page and the entry will come here. So 6 now will become the next data page that basically gets allocated. Now this structure will continue. Okay. Now he will enter all the data here. This will get full. Now he's checking for 2 pages which have free space. Once both the pages are full, then he goes ahead and he will allocate this one, this one, this one, this one, and this one. And all of their addresses will come into the IAM page, which you see here. Okay. And now he's keeping track of every page that belongs to your table called cust. And so in order to find all these pages right now that have data for the customer table, he needs to find the IAM page. And to find the IAM page, he needs to go to a system table. A system table now stores the address of the IAM page. So he picks the address of the IAM page. When you say select star from cust, he goes to sysindexes, picks the address of the IAM, goes to the IAM, and reads all the page numbers which have data here, picks all these pages, goes and reads the data from all those pages, and gives you your result. This is what SQL Server calls in its execution plan a table scan. Because in order to give you a result, you scan all the pages that belong to this particular table. It's called a table scan. As simple as this. Now, SQL Server by nature and the way it is designed. Now, if you're working with databases like Oracle and some other vendors, relational databases, they give you a lot of choices in terms of controlling this allocation, where you can set some parameters, you can set some properties, and you can control the allocation. Do you want to give 1 page at a time? Do you want to give 2 pages at a time? Do you want to give 4 pages at a time? What should be your page size? Should it be 8 KB? Should it be 16 KB? Should it be 32 KB? At least Oracle gives you those choices. SQL Server does not give you those choices. Microsoft have already decided this is good. So the only thing you can do here in this particular in SQL Server is understand how it's used. You will not be able to change any of this. Now, having said that, once 8 pages are full, the way the allocation happens, it's 1 page at a time. I'll repeat, it's 1 page at a time for a particular table until 8 pages are full. Once 8 pages are full, the next allocation, SQL Server says, you know what, this guy is a serious table man. Okay, he's not using just 1 or 2 pages. He's asked me and I've given him 1 page, 1 page, 1 page, and he's used 8 pages. Now, if this guy can basically use 8 pages, there is potentially can use another 8 pages. So why should I give him 1 page at a time? From now onwards, I will give him 8 pages at a time. Are you guys getting the idea? So the second, after 1 page at a time for first 8 pages, when more pages are required, the system will not allocate 1 page at a time. It will allocate a uniform extent to it and give the entire 8 pages now. So the extent address will come here. Let's say this extent address was 001x or whatever. So the 001x now is the extent address will get allocated to your table for data storage. Okay, so this is the primary allocation methods which are basically used by SQL Server. And you visualizing this, understanding this, okay, remembering this will help a lot in your understanding and being able to optimize your queries better as we go to start doing that from our next sessions. Because now you'll start understanding the pages, you'll start understanding IOPS. I will assure you that if you go to attend these series regularly, before the series ends, you will be able to look at a query, count on your fingers, and tell me the IOPS. And when you reach that level of understanding, you can be rest assured you're in control of your query. You know what's happening. You know how to basically change it. You know how to make it better. And you know how to make it worse. Okay. So I'm not going to give you any best practices because best practices, like I always say, is for dummies. It's for the non-engineers because you need to just basically follow a set of practices and they will work. Engineers will always understand things and do things based on their understanding. So that's the objective of this whole set of series of sessions that we're having. And for today, I'm going to basically end at this stage where you've understood space allocation. You've understood how the pages are allocated to your tables. I will pause here for any questions and we'll be happy to take them. I guess no questions like always. So wonderful. Have a great evening, guys. Stay happy and stay safe. Okay. See you guys tomorrow. Do we have a session tomorrow? I guess tomorrow's Friday, right? We have a session on Fridays. I'm not sure. If there's a session tomorrow, see you tomorrow. If there isn't, we see
No
you on
quiz.
Monday. Okay. Wonderful. Okay. Thanks a lot, guys. Very good evening. Bye bye. Thanks, Jess. Bye bye.